So, just to kind of guide me as I go through, we're going to graph 3 of them. That might be overkill, but I guess it's better to be too much. I'm going to go ahead and just draw my tangent curve over here. This is my regular tangent curve. Everybody remember that from the other day? So now we're going to make some modifications to it. So our first one, relatively simple. Let's sketch this. Okay. So what do you notice about the picture? Yeah, first of all, I'm going to turn it around. I don't know why that bothers me so much, but I like to have it like that. It's the same. You don't have to do that. Would you agree it's the same? Okay. So first of all, the point of inflection, remember the tangent is concave down and concave up. That point of inflection is supposed to be on the x-axis. Well, now that point of inflection is going to be moved up to here. Would you agree with that? Well, what else has changed? First, it's going to be upside down, so instead of being an increasing function, it's going to be a decreasing function. Okay, what else has changed? It's moved to the left, pi. So I'm going to go ahead and, I guess I'll just put negative pi here. I'm going to try to keep some kind of scale. This would be 2 pi. 3 pi. All right, some kind of scale here. Now, in a regular tangent curve, the 0 point, the origin, is the origin. That gets moved left pi. So now I've got my dot that was supposed to be at the origin is now here. You okay with that? Now, 1 period later, I only drew 1 period here, but 1 period later, there's another dot. So what is the period of this guy? Pi, just pi. What's the period of a tangent? Pi. Did I put a coefficient here? No, so it's still pi. So I'm going to have my dot here, and then 1 period later, 1 period later. Now, as it so happens, I end up with a dot back on the origin again, because I shifted it 1 period. But all these will be dots. Alex?
Shouldn't they be at 4 though?
Yes, they are. Yes, you're exactly right. Are we okay with, we have intercepts, x-intercepts there? So as Alex says, I moved everything up, so I'm going to move them up here, just like he said. Now, where are my asymptotes? They are always halfway between the dots. So if there's a dot at 0 and pi, isn't there going to be an asymptote at pi over 2? And 3 pi over 2, or 1.5, and negative pi over 2, and negative however many periods we're drawing. Now, when you sketch in your curve, remember these points right here are the points of inflection. So we're upside down, so we're coming in from the top, and then that's where we're curving. So that's where you go from being concave up to being concave down. So certainly 3 periods is plenty, so I'm going to just stop with those 3. But how does that sit with you? Does that make sense? So if you were asked for, all that stuff, like what's the period? Well, we already said the period is pi. So the frequency is 1 over pi. What's the amplitude?
Infinity?
Tangents don't have amplitude, right? So we think of it as the slopes are approaching infinity, but we just say no amplitude. There's no amplitude. It's infinite. It goes forever. Our phase shift, our horizontal shift was negative pi. Oh, by the way, I don't know if you're paying any attention or not, but I let my 3-year-old granddaughter paint my nails. So they're like, she got outside the lines. I wasn't concerned about it because I was just gonna go home and take it off. Well, I don't use nail polish or nail polish remover. So the nail polish remover I had was when my daughters were at home. Well, that stuff is no longer effective, so now I have paint all over my fingers, but it's all right. I'm thinking of Sophia.
Mr. Wooden does the same thing.
He lets his daughters paint his nails.
Yeah.
That's cool. Good dad. All right, let's go on, try another one. All right, see how far, let me do this one together. See how far you can get with this one. Before we get too far into it though, there is something you need to attend to. Does anybody see what that is? You gotta take out the 2, yeah. So make sure before you start sketching that you have taken that 2 out. Pop this negative pi over 16 on here. That's my phase shift. And so that's like my new beginning. So if I think about a regular tangent, the beginning, the origin is right there. So won't that dot now be over here? That dot will be right there? And I know that another dot would be a period away. And what is the period of this? Pi over 2, which in terms of sixteenths is 8/16. So I'm going to have another dot at 7 pi over 16. Does that make sense to you? They're a period apart. And there would be another one back here. I'm not going to do another one, but there would be one back here. And then I know that halfway in between, there'll be an asymptote. So from -1 to 7 is a distance of, well, I was going to do the midpoint. -1 and 7 is 6, and half of 6 is 3. So there's an asymptote here. And since I don't have another dot back here, that's 1, 2, 3, 4. So 1, 2, 3, 4. There'll be one back here at -5 pi over 16. Remember, dot to dot is half a pi. Asymptote to asymptote is half a pi. So does -5 and 3, does that make sense to you? For my asymptotes? Now,
Never mind.
this is another upside down one, and it has a number out in front. So do you remember what that number does? In a regular tangent, halfway in between, look where my fingers are, halfway in between the dot and the asymptote, which in a normal picture would be pi over 4, the point is up 1, right? Well, now, halfway in between the dot and the asymptote, which would be right here, the dot isn't going to be up 1, the dot is going to be up 3. And going the other way, instead of being down 1, it's going to be down 3. Oh, it's upside down. Yep, thank you. It's upside down. Thank you very much. Forgot about that. Now, in reality, that thing is skinnier than normal, but I drew it on a great big wide scale, so it's spread out.
That doesn't matter, right?
No, use whatever scale you've got there. Okay? Now, let's do one more. Now it's videoing you.
Yeah, it's not. Now it's all
That's awesome. It's all right. Doesn't matter. No one watches them anyway. So, yeah, we got it. That case is not very good. I tried to get another one. Yeah. Okay, let's do one more. Anybody have a question about this one? All right, one more practice problem. Here we go. did you have a phase shift of positive 3 pi over 4?
Yeah.
So you should have a dot there, because in a tangent, that's the origin. So we're gonna move our origin, 3 pi over 4, to the right. And then, did you get a period of 3 pi? Pi divided by a third? And I went ahead and I'm gonna think of 3 pi as 12 over 4. So I just marked forward 12 fourths, and that would be another dot. The dots are a period apart. And I marched back and put another one back here. I may not use all those, but now I've got dots. Is that okay with everyone? And then what do I know about my asymptotes? They're halfway in between the dots. So what's halfway between 3 and 15? 3 plus 15 divided by 2, 9. So an asymptote here at 9 pi over 4. And then I'll have another asymptote at negative 3 pi over 4. Is that all right with everyone? I'll make one more back here. This will be negative 15 pi over 4. So every 12 fourths, there will be a dot. And every 12 fourths, there will be an asymptote. Does that make sense to everybody? Everything's evenly spaced. Okay, now this one is a positive tangent curve. Its point of inflection is going to happen right there, up 1. It's going to go up, but I stuck a 1/2 out there. Now remember, let's say I'm going to graph this period right here. I know I'm going to be coming up like this. Halfway in between the dot and the asymptote, I should have a point that is exactly 1 above my point of inflection, right? That's normal tangent. Halfway in between, which should be right here. But because of that 1/2, that point isn't going to be 1 up, it's only going to be 1/2 up. And on the other side, it's going to be 1/2 down. So what does that do to my picture? Doesn't it make it curvier? Like less straight? Makes it curvier because we have smooshed that curve down. That's one period of it. The other periods would look exactly the same if you need to graph more than one period. Okay, so I will go ahead. Sorry about my hat. All right, let's run through the stuff again. What is the amplitude of this curve? There isn't one. The period is 3 pi, making the frequency 1 over 3 pi, right? Not 1/3 pi, 1 over 3 pi. Your phase shift was 3 pi over 4 to the right, or positive 3 pi over 4. and your vertical shift was 1 for your midline. Everybody okay? So tomorrow I'll give you an equation like that, and you will do what we just did. Good? All right, let's do a little more practice with the tangents. Let's get our notes back out. The other day we did the front page 5, but I'd like you to do the back of page 5 and then page 6, front and back. And when you get some answers, how to do this, because they're not numbered, I'll figure it out. We'll put some answers up there on the board when you get ready. We're starting at the back of page 5, and they're not numbered. And we're doing page 6 and page 7. And feel free to put that away before I absolutely get out of here. We're going to, feel free to get up and go check answers with somebody else if you have a question about something. If you're not sure and your partner doesn't know, you can go get help from someone in the know. Back of page 5, that's where we're starting. And then we'll do page 6, front and back. And then we should have the tangent pretty well down. Kind of made the pages up here. So here are the 6 problems. When you get an answer to any of those, go ahead and bring it on up. Oh, I catch everything. So that's 5 back. And those are
After
slots on the page.
through the things and normal, all you're doing is you're changing the points where they are and midline. So ask them to do the same as normal.
Oh, yeah, 'cause you only run
running
up.
away.
Where were you running away? I'd yell at you too, it's lazy.
I mean, he's not wrong though.
Yellow starters.
Are you serious?
I'm red.
Yellow starter?
Red starters. He's an orange starter.
No, you're orange. You're no, Cole, you're orange. You're orange. You are. It's the art, bro. It's the art.
Alright.
It's like the the like.
I think it's just the hair. It's the aura you get from it.
No, I'm saying it's. I'm thinking of like your the vibe, like the color.
Anybody else done with back or five?
Me?
Check your answers. Okay, Fred agrees with all of those answers.
Like, I'm not even
Is
trying to
there
be like
anybody who has a question about any of those answers?
Herb?
What do we know about the tangent curve, guys? Isn't it always increasing? Right?
Yeah.
Always increasing. When we talk about increasing at an increasing rate, we're talking about concave up. Concave up, so we find parts of the graph that are concave up. Good. All right, let's keep working. I'm not on. Let's go to page 6 and see what we can get there. I think those are all right. Okay, so yeah, you need your calculator because that's how you do it.
Was originally written -5 before 5 before, but then now just leave that.
Yeah.
She said she's
That, because when we change
Guys, let's get page 6 down. Yeah, for page 6, you're gonna need your calculator for part of it.
Halfway through from the middle to the right after. So that's why it was more of that. So it's just narrow up more in the middle. Yeah.
No, so that, okay, so
Kelly.
I Oh, okay, so ratio of vertical to horizontal display digit.
That makes sense because.
Or do you want to text me?
So the ratio.
You want to text me? It's really good.
Right now, I'm trying to do math.
That doesn't work. Like next to me.
Stop it. Anybody got answers to page, or to the second page there?
I know Enzo.
I'm locked on the graphing, but this stuff just doesn't fit.
I'm starting to figure out the graphic, but like do stuff.
I know the graphic. That's all I need for tomorrow. All I need for tomorrow is the graphic.
Exactly what I'm saying. Remember, if it negatives in the front, that means it.
Flip it.
Flip it upside down.
That's all you gotta do.
You graph the tangent upside down and flip it the exact same way.
No. One goes this way, one goes this way.
Like, if you do this, you flip
It's like an odd and even function. No.
Yeah.
No. Look, if you're going, look, Pat, what are you saying?
I'm saying, at the tangent,
Yeah.
upside down, it's
Okay,
the
but.
same.
Oh, but no, you don't flip it upside down.
Right, this is
You know what I'm saying?
vertical asymptote. Different midline and a different. Where they intersect.
Oh, you're saying that. So it goes one over.
Yeah. If you want to describe
Yes, they're the same. All right, so some of us are struggling a little bit with this. So would everybody agree that, for, like Helen said, for the, we're on or page 6 here, for the first one, would you agree that the asymptotes are the same as for the regular tangent? How do we know that? There's no horizontal change. So wherever the asymptote was, that's where it's staying. And where are the asymptotes? At pi over 2, 3 pi over 2, 5 pi over 2. So remember, look at my black writing up there. See, that's how we wrote it the other day. Remember that? So those are my asymptotes. All right. Now, Kellen or somebody said that the answer to the other one in the top row is 3 pi over 4. I didn't get that, but I don't know if I'm right or wrong.
Sorry for backing, but what does the N?
A whole number? Any whole number?
What is it? The E is just N?
Yeah, N means an element of that set. It is one of those. It's just a symbol for is an element of. Set notation we learned a long time ago. The problems in the second row and the first one, these empty ones here, these guys, I want you to look carefully at the question. Isn't it just asking you for the tangent? When it says B over A, look at how they labeled it. Isn't that Y over X? And Y over X is the tangent. So for this problem right here, if they'd have said 2 pi over 3 radians, wouldn't you have just gone to your unit circle and found the tangent at 2 pi over 3? Well, 4.1 is not on my unit circle, so I'm gonna go to my calculator. I'm gonna make sure it's set in radians, and I'm just gonna find the tangent of 4.1. And it's gonna be a decimal, and that's gonna be your answer here.
What's the like E?
That means is an element of. So when I say pi over 2 plus or minus pi n, I need to know what's n. N is an element of the set of whole numbers. So n is a whole number, like 0, 1, 2, or 3.
Okay. So it's saying like what type of number n has to be?
Exactly. Because n can't be 2/3. It has to be a whole number for that to make, for that to be right.
Is it like, can you do that with like real numbers and like?
You can. Now, you wouldn't in this case, but you can certainly say n is a real number, n is an integer. He will often in his papers write this like this. Because if he lets his n be an integer, that would take into effect the negatives. If n is a whole number, I need to put the negatives in. This is the way I have always written it, but this is the same thing. All right, so for this one, we just typed tangent 4.1. I got 1.42, did you? I didn't write down all the decimal places, but is that right? Over here, I did tangent 2.6. Now, you could, if you wanted coordinate A, how would you find the x coordinate A? Cosine. Could you find B using sine? But since you're looking for the ratio of B to A, we'll skip all that and just find tangent.
So are we never gonna have one of these type of questions on a no calculator test?
You can't. I can't, you can't, no one can. All right, and then this one was the same thing, only your angle was 5.06. Did you get a negative answer for this one? Makes sense, because 5.06 is in quadrant 4, and the tangent of quadrant 4 is negative. All right, so these three right here, we're just typing a tangent into our calculator, making sure that our calculator is in radian mode. Good?
Good.
Domain. Domain for the cosine and sine. Now, he said infinity, and he's right, but we should say negative infinity to infinity, right, for our domain? Our domain's everything for sine and cosine. Tangent, our domain is everything except where the asymptotes are. Right? So it's not, these are the asymptotes. Domain is everything except those places where you have asymptotes. We talked about that the other day, I think. All right, anybody have a question about that? The front of page 6. All right, let's get the back done. You should not need a calculator for these problems. You should be able to do these problems without a calculator. Stop singing and start doing.
We go try.
I'm not.
Try. Yeah, you try. What do you say?
He said the best way to spread Christmas cheer is to make sure that all can hear the singing bug. I have, it's just been like 10 years.
Okay, right now I want to spread pre-cal cheer, okay?
There's no cheering.
Yes, there is.
Mom, when you understand
I believe on these problems, when it says give the two smallest non-zero, they mean positive. So we want the two smallest positive.
saying.
No, X intercepts. It's hyphenated. Random, is focused. And the slots over there. Nicole's got us started here.
I can do the rest if you want me to.
But it won't change the.
Just
Okay, Alex, my friend, you got answers up there, are you checking them? Oh, here comes that one. I don't know what that means. Adding it.
I got a different answer. The last one I got 5 or 6, right? Because it's already outside of the I just think that since it's
So
not
you
multi-
think it should be pi over 6? I'll add
Which
it.
one?
That's what I think. Because it's not multiplying the x. And like either way, it's going into the tangent. So those outer parentheses don't really
Okay, so for the first one and the last one, we have some, discussion. Are there any others we have discussion about? Yep,
This is another one, but I thought that the bottom right was series of two.
I don't know. I'm just saying we had discussion. So your vote is with 6, okay? Somebody else's vote was different. So what do we think? All right, let's talk about the ones there are no discussion for first. So everybody is in agreement that this one right here should be pi over 4 and pi over 2? In terms of tomorrow, You need to know what a tangent looks like, right? For graphing tomorrow, isn't this your normal tangent? So the period of that is pi. So every pi, there will be an x-intercept. So for the normal regular tangent, the x-intercepts, the dots, the zeros, are at 0, pi, 2 pi, and so on. Well, in problem number, this one, we divided our horizontal by 4. So these guys aren't going to be here anymore, and these aren't going to be here anymore. They're going to be divided by 4. Everything's going to be divided by 4. So I think that's right. This one, same argument, only we're dividing by a half, which means we're timesing by 2. So this was pi and 2 pi, is now going to be 2 pi and 4 pi. Beautiful, beautiful. And then this one, we're dividing by a third, timesing by 3, 3 pi and 6 pi. I think that's great. So let's pop back up here. Cool, you guys did great here. Let's come up here. These are the regular intercepts for the regular unmodified tangent. So when you put that 2 in there, you're going to divide these by 2. Everything horizontal is being divided by 2, so you would be at pi over 2 and pi. Okay? The same as the ones you got right, so I'm not sure what happened there, but yes. All right, and then we have to find the period. So for this one, the period would be pi divided by 1.5 pi, which is 1, the pi's are going to cancel, 1 divided by 3/2, which is 2/3. Beautiful. Everyone agree? You were right. This one, there was a little bit of conversation about. It's going to be pi divided by pi over 6, which is pi over 1 times 6 over pi. So whoever did that originally, that is the answer. 6 is the period. All right, Cole, you paying attention?
Yes.
All right, we good on all that? Okay. One more quick comment to get us ready for tomorrow. Tomorrow, after our quiz, we're going to start our 7 notes. And our 7 notes are about the inverse trigonometric functions. There are 2 notations. It doesn't really matter which one you use, but the 2 notations for the inverse sign are these. You will see this one on your calculator. Have you seen that one? That one's on your calculator. It's inverse sine. This is exactly the same concept. It's just a different notation. So tomorrow we'll kind of be using both notations. Those are notations for the inverse sine. All right.
When's our next homework due?
Oh, 3/8. 3/8 is due.
Tomorrow?
This is my
Did I already sign that?
Yeah.
Due tomorrow? I can't remember. I signed it. I can't remember.
No, I swear to God, I'll take you to basketball.
Yeah, 3/8 due tomorrow. Okay, last was asking. All right, I have some NHS materials I'm going to be handing out. I'm going to ask each of you not to open it until you leave the classroom, but I do want you to be very careful with the staple. We're trying to conserve resources, and so I didn't use envelopes, so be very careful when you leave the staple. Be very careful.
You literally
A
look like
lunchbox on the floor, please.
No, you look like Boo. Brother, you got George.
All right, here's prayer.
As we head into the Lent period, let us pause and be mindful of all of God's blessings. If you're in the hallway, please stop. In the name of the Father, Son, and Holy Spirit. Lord, thank you for the food before us, the Irish family and friends beside us, and the love between us. In Jesus' name we pray. Bless the Lord and these thy gifts which we are about to receive from the God of Christ our Lord. Amen.
Thank you, Ms. Ford.
All right, confession from 12:15. Yes, I'll see with Father Joey. And mass at 11:50 and confession at 12:15.
So,
What's good?
and while it may not be a big deal for you, but things like uniform, tardiness, all those things are very, very important when you're setting an example. No, I had office hours today. Where were you? I did it on Monday, Wednesday, and Friday. I don't have any control over that because we have meetings on Tuesdays and Thursdays.
I missed some days last week when I was real sick.
Really sick?
Yes, ma'am. Couldn't get out my
Making
bed.
that up.
No, I'm not. I promise.
You promised you were really sick?
Yes, ma'am.
We're gonna practice a little bit. It's still